So what team are you guys?
We are the
Panda-Monium.
Where are you from?
Holy Family School in San Jose.
You guys do a rundown of your robot, so all the different places you attach things. And...
Okay, let's see.
Thank you.
So the first thing we have here is we have a color sensor right here, and then we use this to go over the white and black lines. Vicky, you want to talk about the shield?
Okay, so if you notice, we have these black bars covering the color sensor. These are used to shield it from any random light rays that might interfere with its sensing.
And right here we have this ski contraption, and the reason for that so it can go through thermostat action.
And then we have the arm motor on this side, which helps us attach one arm on that side.
So you have these big wheels right here, very wide, and so the width is so that we could keep traction, and the size is so that it could go over a larger distance with less power.
And we have these two motors on the bottom connecting to the wheels that move the wheels, and we have them there so that in the bottom in the middle, so that there's not front or top front heavy or back heavy.
And we have on the bottom also two metal balls, and this is because so the range of motion for the back is very wide, so that it can do full circles with no problem.
Another reason we did the balls is because we were having a problem where we had wheels in the back, and because of the weight of the robot, the wheels would bend. And with these balls, it allows the weight of the robot to be supported directly straight to the ground.
So can you guys do a run through of your different attachments?
Okay, so
Start with yours.
Start with that one.
we'll start with this one. This one, it's used to distribute the different pellets to all the animals. And then what it does is the arm falls down, and then two of the pellets are distributed by the weight of the arm. And what's good about this is that not only does the arm not have to go up and down twice, but you can complete all of these in one mission. And then we attach the arms using a key system, and this saves time because all you have to do is line them up and stick the key through, and then it's off.
And a way to make that more efficient is for the small arms. We have this, an arm insertion piece, so that it can make it so we don't just forget that we misplace it. So we just slide it in and put the key system in. So this helps us with efficiency and no pieces get stuck.
Okay, so this is the next arm that we have. This one is used for grabbing the bee and the pig. It'll go out and it'll just come down and it'll come back. And the reason it has these little prongs that keep is so it was originally used to grab other materials that might have slipped underneath it if they had gotten caught in the wrong spot. So as long as we have these down, nothing can escape from underneath and get caught up in the robot.
Okay, so this one is used for getting the shark over to its destination. Here, can you put that in?
Yeah, put it in. So
Yeah, we just put the shark in here, and then it just goes forward to the destination, drops it off, and comes back.
And the next one we have is, this is the one arm that we've ever had that doesn't use a key to be attached to the robot. What we do is we just tuck it under here, and the wire holds it into place. And then this one goes up here using a key. And then this one, a robot goes right up to here, and it just goes like that over and over again. And it dispenses all the pellets, and then it comes back to base, and then we remove it.
So have you used this design in previous years or a variant of it?
Each year we try and do a different strategy. Like for example, right here we have a color sensor, and it flips up because it gets in the way of some missions, and we've never done anything like that before.
Did you ever redesign your robot?
No.
Not
No.
this year.
No.
Well,
Not this year.
we add stuff to it, but we don't technically redesign it.
Have you ever combined different attachments into one attachment?
Yes. For this one, it was originally used to collect the honey from there, but now we use to hold a pig and drop it off in the field.
Another example would be this one. This one is not only used to distribute the dog trainer, but during the mission, so it starts off with the dog trainer. During the mission, it grabs the girl. So it does two things, and then it drops them off here, and then it also retrieves the camera.
Okay, so then more than attachments,
Oh, yeah.
we have aligners like these that we can use to align the robot for certain missions so that it's accurate. And this one I think is used for the shark mission.
Yeah, that one.
You can just put the robot in here. Oh, I think I did that wrong.
No. So we usually align it using the black lines of the edge. So we will like put it this way and just slide it in, and then we usually just have it like touching the wheel or something, and then as soon as the other person has put in the arms, just slide it out, and then you can roll.
We also have some features that aren't necessarily physical, but they're robotic, like they're programmed. And Adam, would you like to explain?
One of them is it's a program selector, so when you run it, you can just go down and up, so that
Makes it easier to select programs so that you're not sorting through the entire list.
because in previous years we had problems where sometimes we'd get caught trying to find our program and we'd run out of time.
So that's a custom program you made?
Yes.
Yes.
Do you use a line following program?
Yes. Adam here has created a line follower program, and he's tailored it so that it can be adapted to follow any line. And this year he even made it so that it can follow this line around the circle.
All the way here.
And then another it's sort of like a line follower, but not really. We had a problem where sometimes on the mat, like for example, the color sensor would detect this as black, and then this blue tint as white. So we created something we call the line pass, where the robot goes forward and it says, okay, I found white, and then it starts counting how many degrees and says, okay, if in 15 degrees I find black, then I must have the right line. But then to make sure it doesn't have the wrong one, it goes forward another 15 and says, okay, do I have white again? And then if yes, then the robot knows that it's found the right line and stops.
Do you use a gyro?
No.
No, we do not use a gyro.
Do you calibrate your light sensors?
Yes.
Yeah.
Yes, we do.
Do you use the built-in calibration, or do you have a custom program that does that?
We use the
Okay.
Built it.
So what mission was the hardest one to get working?
We call it milking automation, but it's the first trip, it's the longest trip, and what it does is, Adam, would you like to explain what it does since it's your mission?
So
Yeah.
basically the mission, it goes around here to get the milk out, but while it's going around, it's also carrying this, and it also picks up the girl. And then since we decided that since we are close, we'd drop them off here. And then we decided that since we are so close to a bunch of missions, we would alter the arm so that while it was holding these, it could drop them off into this box easily. And then and we also have this on here so that this guard doesn't fall off while he's hanging on it.
And then after that?
And then after that, he grabs the seal,
No, not the seal, the camera.
or the camera from the seal. And then we combined with another mission, and we kind of just were able to just put it right on it without having to change any of the program, so that I would put the gecko on the wall.
Yeah. So I designed this arm specifically for this purpose, to go up and then deploy the gecko like that, and then just back away so that it just hangs there. And then it turns around, does some line following to make sure it's found it, turns a little bit more, goes right into base.
What is the best possible score you guys can get?
It's
100.
in the 200s because we get 80 if all the feeding pellets work.
27 for the shark.
27 for the shark. This one generates, this trip generates 87 points. And then we could get the bee and the honey. And then we could get the prosthesis in this area with the wheels.
And the bee.
On the house.
So we haven't tallied them all up because we've never had a situation where every single one works. But it's in the 200s.
Did you build more than one copy of this robot?
No.
No.
This is the existing copy of this.
How often did you guys meet on average?
Okay, so we meet Saturdays, Sundays, and then as we get closer to competition, we start meeting on Wednesdays and Fridays too.
So anywhere from 2 to 3 weeks, days a week.
And then its practice are usually 4 hours?
3 to
2 to 4.
3 to 4.
Yeah.
4 hours.
Sometimes even 5.
Yeah.
How did you guys get into FLL?
Our school, one of the extracurricular activities that our school has is robotics. And so us three have been doing it since 4th grade, so this is our 5th year. And then they sort of joined in. He was also with us in 4th grade. And then, were you in 5th grade too?
Yeah.
Yeah.
2 years, and then I quit for 2 years, and then I came back for this year.
And then she's new
I'm
this
new
year.
this year, so I've never done anything with to do with robotics. Like, I don't know, my dad had a kid at home, and I play with it sometimes, but not fun. But then I did a camp, and then I decided, hey, what if I join? I mean, like, if I join it, like, the whole team is all boys, so I'm like, well, I don't know. But then I did it anyway, and I had fun.
Yeah, she's pretty good at it too.
Very good
Yes.
at robotics.
Yeah, very good.
And Nick, you want to say when you joined?
Well, the reason I joined, because during 4th grade, I didn't know what robotics was like or what it was about. And during the open house, when I saw the robotics, I thought it looked fun, so I decided to join.